Artificial intelligence is progressing faster in mathematics right now than in literally any other field. It's wild. Let's dive right into this explainer and explore why this fascinating anomaly is actually a crystal ball for our future. It signals exactly how AI is going to evolve and eventually impact the rest of the world.
So, we got to start with a really provocative question. A few years back, people were wondering, if an AI can cold solve the absolutely hardest contest math problems in the world at the International Math Olympiad, does that mean we've achieved artificial general intelligence? Like, does it mean the AI can now do any white-collar work a human can do? Well, the short answer is no, it's really just another benchmark. But to understand why, we have to look under the hood at how AI actually thinks.
Here is our roadmap for today. We're going to hit AI at the Math Olympiad, lightning bolts versus mountain building, the 100-year verification loop, the grindability of math, and finally, the future of the human mathematician. We're mapping out exactly how AI learns and what its evolution actually means for the future of human intellectual labor.
All right, Section 1, AI at the Math Olympiad, Benchmarking Intelligence.
When you look at the Olympiad results, the AI absolutely crushed geometry. I mean, it cold-solved insanely complex problems in like 19 seconds flat, mostly because it could just use a massive brute force approach. But it struggled heavily with combinatorics. You know, those problems are just much more playful. They require real human-like creativity and intuition, a vibe the AI just doesn't quite have yet. Honestly, if the tests had just featured more geometry, the AI would have easily taken home the gold. So AI capabilities right now have this sort of fractal spikiness to them. The models are superhuman at some very specific mathematical tasks, yet they completely stumble on others that require creative leaps.
Moving on to Section 2, lightning bolts versus mountain building, the nature of discovery.
We can categorize major mathematical breakthroughs into two totally different buckets, lightning bolts and mountain building. A lightning bolt is when you manage to connect two completely distinct fields. Think of the famous story of Hugh Montgomery and Freeman Dyson having lunch together and suddenly realizing that the statistical behavior of prime numbers in the Riemann zeta function perfectly matched the energy levels of a nucleus in random matrix theory. Just an incredible spark of connection. Because AI has this vast superhuman breadth, like it's read every physics paper and every math paper ever written, it is totally primed to throw these lightning bolts very soon. But mountain building? That is fundamentally different. To solve Fermat's last theorem, human mathematicians had to build massive, entirely new conceptual frameworks over decades. Things like modular forms and elliptic curves had to be invented before they could even connect them. AI might be fantastic at throwing lightning bolts between existing mountains, but building entirely new mountains of theory, that remains a profoundly different level of intelligence.
There's this fantastic old adage in math that goes, good mathematicians prove theorems, great ones come up with conjectures, but the greatest mathematicians come up with definitions. If an AI is just proving theorems, it's doing great work, sure, but it's ultimately kind of a parasite on the human who came up with the definition in the first place. The ultimate benchmark for an AI won't just be solving an existing problem, even a huge one like the Riemann hypothesis. It's going to be generating the brand new definitions and objects that build a whole new mountain.
Which brings us to Section 3. The 100-year verification loop, or the difficulty of reward.
Right now, the heavy lifting in AI training comes down to RLVR, reinforcement learning with verifiable reward. Basically, this means giving the AI a very clear goalpost. You solve the problem? Boom, here is your reward. You fail? Try again. AI thrives when that reward is immediate and measurable. But here is the massive problem. True conceptual breakthroughs in science often lack any sort of immediate, verifiable utility. Just think about the incredible history of group theory for a second. First, Lagrange plants the seed of thinking about symmetry in polynomials. Then, a young teenager named Évariste Galois tries to abstract this into a whole new theory. His notes get rejected by the Academy because they were, frankly, barely coherent to anyone else. Then, tragically, he dies in a duel over fractured romance at age 20. It wasn't until 20 years later that Liouville actually found and published Galois's notes. And then it took another 100 years before a physicist named Murray Gell-Mann used that exact math to predict the existence of quarks in the 20th century. The verification loop for group theory took over a century. So the question is, how on earth do you design an RLVR environment to reward an AI for an instinct that won't actually prove useful for 100 years? That is the grand challenge of AI mountain building.
Okay, Section 4, the grindability of math, and exactly why AI excels so wildly here.
The secret ingredient to AI's massive current success is something we call grindability. Think about asking an AI agent to go navigate a shopping website to buy you a pair of shoes. It takes a massive amount of compute, the website's constantly changing, and eventually, the AI just gets shut down by bot detectors anyway. It's incredibly high friction. Math, however, is perfectly grindable. A model can just farm the simulator endlessly, running thousands of parallel attempts instantly without ever getting blocked.
And this highlights the inherent advantage of digital minds. Real-world tasks are full of messy entropy. You've got bot detectors, CAPTCHA, and really hard credit assignment, meaning if a business plan fails, it's nearly impossible to tell an AI exactly which step went wrong. But the mathematical universe, it's totally deterministic. It's easily containerized. Digital minds can universally apply their capabilities in parallel across this entire universe, learning precisely what worked and what didn't. Zero real-world pushback.
Because of this setup, imagine this scenario. We could very soon see an AI interacting with something like the Lean MathLib. Now, this is a massive repository of math written entirely in code. You could essentially press Go on an AI, and it could endlessly run an infinite loop, formally verifying its own proofs, extending the tree of logic, and exploring the mathematical universe for 10 years straight, without a human ever needing to check in or correct it.
Finally, Section 5, the future human mathematician, curation and guidance. Let's answer the big existential question here. If an AI can run in an infinite loop, proving theorems and building new mountains of theory, what exactly is left for humanity? Well, historically, the role of the mathematician was all about climbing the mountain, right? Proving the theorems, finding the solutions. But the uplifting answer to all this is that the theorem-proving economy will likely transition into a curation economy. The future mathematician is going to look a whole lot less like a human calculator and a lot more like an art museum curator or a social guide.
So, here's the main takeaway you really need to internalize. Humans provide completely unique value. We are absolutely going to need curators to navigate the nearly infinite space of AI-generated ideas, just to decide what is actually worth engaging with. Because even if an AI writes a completely flawless paper, human beings still crave social motivation and relationships to actually get interested in a topic. We'll need expositors to distill these dense, alien AI discoveries into human understanding. And crucially, someone has to look at the massive behemoth of new, AI-generated pure math and figure out how to point it toward practical, physical applications in engineering and science. Roles like teaching, explaining, and curation, they're going to be some of the most incredibly stable jobs moving forward.
We've explored the fascinating, kind of spiky frontier of AI and math today. But wrapping up this explainer, I want to leave you with a provocative thought for your own life and career. When AI inevitably automates the grinding and the mountain building in your specific field, how will you step up to curate the view? Thanks for tuning in, and we'll see you next time.